Let's talk about functions. It's a fun unit because, it wouldn't be called functions if it wasn't fun, right? Okay, anyway, so I'm going to start just by reviewing quadratics with you, aka the graphs of quadratics, meaning parabolas. So, we got our lovely vertex represented by the letters HK. We have our axis of symmetry, which is the equation x equals h. Our domain, that's all possible x values, and it's always from negative infinity to positive infinity. Our range, remember, that's bottoms up, so it's lowest to highest point. So in this situation, because it's facing up, or opening up, the lowest is k and the highest is infinity. We put a bracket because it definitely hits. If it was something like this would be from negative infinity to k, because k would be the highest y value at that point. We also have our intervals of increasing and decreasing. This will also depend on which way it's facing, but honestly, with these two, I would just suggest that you trace from left to right. And please remember that it's based off the x values. So what intervals of x is your parabola increasing, decreasing? So if I was to trace this one on the left here, from left to right, I see that I'm going down until I hit h, which means that going down is decreasing. So from negative infinity until h, I'd be decreasing. And then on the other side, I start at h, and then it goes up. So increasing is until infinity. If it was downward, those two would be switched. With quadratics, remember we had 3 different forms of quadratics. We have standard form, we have vertex form, and we have intercept form. So P and Q represent your x-intercepts, HK represents your vertex, and from standard form, C, that's going to be your y-intercept. And the vertex from standard form, I want to remind you that H is opposite B over 2A. And to find K, you're just going to plug whatever you got for H into your equation for X. So that's just a really brief summary of parabolas for you. And I want to focus more on vertex form, mostly because I want to talk about graphing transformations. A transformation is how a parent graph has been moved. And so just know that with this form, like vertex form, we talk about with graphing transformations. Absolute value graphs we could talk about with transformations. We could also, I could throw in any kind of equation into this form, really. So I could do a square root graph, which you didn't even know how to graph that, but point is we could talk about it in terms of transformations. And so the big thing to know here, starting with A, A is going to be a vertical stretch or a compression. And also, if A is negative, it's going to represent a reflection over the x-axis. So when I'm talking about vertical stretch and compression, I'm going to talk about the absolute value of A being less than 1 or the absolute value of A being greater than 1, because the negative just signifies a reflection. So if the absolute value of A is less than 1, we call this a vertical compression. And what that's going to do, a compression, so if you had your normal parabola, a compression is going to take it and it's going to make it wider. I remember learning like fraction makes it fatter. So a compression, it makes your parabola wider. Okay, so now if it's bigger than 1, we have a vertical stretch. So what that's going to do is it's going to make your opening narrower. Okay, next we're going to talk about H. H is going to represent a horizontal shift. Sorry, there's so much background noise. I'm outside my house. And I'm writing down opposite direction because I want you to notice that it's minus H in here. So for example, if I had like a y equals x minus 2 squared, because it's a minus 2, I might think, oh, it's going to move to the left, but the equation says opposite. So this is actually a horizontal shift to the right 2. And then we have K, which represents a vertical shift. And that one's like normal. So let's give an example. You have to name the transformations. I'm going to do 2 examples. Okay, so for my first example, I'm going to say because the A value is 3, which is bigger, we're just going to call it a vertical stretch of 3. And I see that there's a horizontal shift. Right 7. And a vertical shift down 6. My next example, the first thing I see is a negative. So I got a reflection over the x-axis. I have a vertical compression of 1/2. And then I can see there's a horizontal shift. This time it's to the left because we're going opposite. So it's to the left 1, and then I have a vertical shift up 5. Yep, so really with transformational form, it's really more saying where's the placement of the vertex. I want to remind you that with an absolute value equation, let's do our parent graph of that. It's a V shape of a graph, vertex at 0, 0, and the A value just determines the slope of the lines going in either direction. And with a parabola, remember we got our 1A, 3A, 5A growth factor, and so that is how you would graph it from there.